So solving differential equation by Laplace transform. So now to solve the differential equation we have to use the following formulas. So these are all important formula. To solve the differential equation we have to use these three formulas. Laplace transform of y of t is equal to y bar. Laplace transform of y dash of t is equal to s into y bar minus y of 0. Laplace transform of y double dash of t is equal to s square y bar minus s y of 0 minus y dash of 0, etc. It may be Laplace transform of y triple dash of t can also written as s cube y bar minus s y of 0 y minus that means s cube means s square y of 0, s y dash of 0 and y double dash of 0. So etc. we can write many more formula like this. So to solve the given differential equation we have to use Laplace transform method. For this we have to use these formulas. Okay, the first problem, solve y double dash plus y plus 5y dash plus 6y equal to 2 given y dash of 0 equal to 0 and y of 0 equal to 0 using Laplace transform. So to solve this differential equation I am going to use Laplace transform method. The given differential equation I am going to write in terms of t, so that the given differential equation can be rewrite as y double dash of t plus 5y dash of t plus 6y of t is equal to 2. So the given equation I am going to write in terms of t. So now this differential equation I am going to take Laplace transform on both sides. So taking Laplace transform on both sides. So when you take Laplace transform on both sides, L of y double dash of t plus 5 into L of y dash of t plus 6 into L of y of t is equal to L of 2. Taking Laplace transform on both sides. Now I am going to use the formula. You know the formula for L of y double dash of t. So this is the formula. L of y double dash of t is s square y bar minus s y of 0 minus y dash of 0. This formula I am going to apply here L y double dash of 0. So what is L y double dash of 0? S square y bar minus s y of 0 minus y dash of 0. So this is for first one. And plus 5 into L of y dash of t. What is L of y dash of t? This is L s y bar minus y of 0. So this is the second formula, L of y dash of t. And plus 6 into L of y of t. What is L of y of t? L of y of t is y bar. So this is y bar is equal to Laplace transform of 2. Laplace transform of 1 is 1 by s. Laplace transform of 2 is 2 by s. So this is 2 by s. And now here we have y dash of 0 equal to 0 and y of 0 is equal to 0. So put these two values. Put y of 0 is equal to 0 and y dash of 0 equal to 0 in above. So that this becomes s square y bar minus y of 0 is 0, y dash of 0 also 0, plus 5 into s y bar minus y of 0 is 0 plus 6 y bar is equal to 2 by s. Okay, now here each term having a y bar term. If any other term not containing y bar, you can take into right hand side. But there is no term not containing y bar. So all the terms are containing y bar. So take y bar term outside. So that it becomes s square plus 5s plus 6 into y bar is equal to 2 by s. Because each term take y bar outside. So s square plus 5s plus 6 take y bar outside. So now from this we can find y bar. What is y bar? Y bar is equal to 2 by s into, take the term here, s square plus 5s plus 6. Okay. Now what is y bar? Y bar is L of y of t. So for y bar I am going to substitute L of y of t. So now L of y of t, for y bar I am going to take L of y of t, which is equal to 2 by s into this s square plus 1, s square plus 5s plus 6 can be factorized to 6 can be written 1 into 6, 6. This cannot use, so 6 can be written as 2 into 3, 6, and adding this 5. So this can be factorized like s plus 2 into s plus 3. Okay, and now I want to find out y of t, because in the problem y of t is a solution of the differential equation. So that take L here, right hand side. So that this becomes y of t is equal to L inverse of 2 by s into s plus 2 into s plus 3. Take equation number 1. So now you know already we can apply partial fraction method. Already we done the problem, so now I am going to apply partial fraction method, then we will get the answer of the problem. So now I am going to apply partial fraction method. So by partial fraction, 2 by s into s plus 2 into s plus 3 is equal to a by s plus b by s plus 2 plus c by s plus 3. Okay, so now I am going to take LCM and cancelling the denominator. So 2 is equal to a denominator is s, so cancel s, the remaining terms are s plus 2 into s plus 3 remaining terms, cancelling s remaining term. B denominator is s plus 2, cancel s plus 2, remaining s into s plus 3. So b into s into s plus 3, cancelling s plus 2, plus c into denominator is s plus 3, cancel s plus 3, remaining s into s plus 2. So now I am going to find a, b, c by putting any other value for s. So first I am going to put s is equal to 0. So because when you put s equal to 0, this and this cancel. So that 2 is equal to, put s is 0, so only 2, and put 0, 3. This becomes 0 into anything 0, 0 into anything 0. So from this 2 is equal to 6a, which implies that a is equal to 1 by 3. So we found a value. Similarly I am going to put s equal to minus 2 and s equal to plus 3. So now I am going to put s equal to minus 2. So put s is equal to minus 2. So when you put s equal to minus 2, 2 is equal to, put s equal to minus 2, 0. Put s equal to minus 2 here. So b into minus 2 plus 3, and put s equal to minus 2 into 0, so c term 0. So now 2 is equal to b into, here 3 minus 2, 1, 1 into minus 2, minus 2, which implies that b is equal to minus 1. So we found b value. Next I am going to put s equal to minus 3. So put s is equal to minus 3. So 2 is equal to, put minus 3, this become cancelled 0, plus put s equal to minus 3, b term also 0, plus c into, put s equal to minus 3, so minus 3 into minus 3 plus 2. So now 2 is equal to c into, this cancel minus 1, so minus plus 3. So you see, this is minus 1, minus of minus plus 3, 3c. So finally c is equal to 2 by 3. So now we found a, b and c. Substituting these values in equation number 2. Because already we took this is 1, so this is equation number 2. Substituting all the values in 2, we can find L inverse. So substituting the values of a, b, c in second equation, we will get like this. Because the second equation is this, a value is 1 by 3, substituting 1 by 3, 1 by 3s. B value is minus 1, so minus 1 by s plus 2. C value is 2 by 3, is 2 by 3. So this is the value. And now substituting these values in equation number 1. because equation number 1 is, this is the equation number 1. So here this is the value, we found this partial fraction. So substituting this value in 1. So 1 implies that y of t is equal to L inverse of, this is the value, this is we found this. So 1 by 3 by s minus 1 by s plus 2 plus 2 by 3 by s plus 3. Okay, now I am going to take L inverse inside. So now 1 by 3 into L inverse of 1 by s minus L inverse of 1 by s plus 2 plus 2 by 3 into L inverse of 1 by s plus 3. So now 1 by 3 into L inverse of 1 by s is 1. L inverse of 1 by s plus 2 is e power minus 2t plus 2 by 3 into L inverse of 1 by s plus 3 e power minus 3t. So finally this is the solution of the given problem. So 1 by 3 minus e power minus 2t plus 2 by 3 into e power minus 3t. So this is the solution of the given differential equation using Laplace transform method.